Yeah. Okay, so hi everybody. Today we have a Div3 round, and yeah, this will be an unrated round for me. So another 10 seconds to go. I'm a bit late, so there is not a big intro this time. But yeah, let's see how this one goes. Now there might be some background noise in at my side, so pardon me for that. But yeah, I don't know what just happened. Okay, seems like some issue with the Codeforces servers again. Okay, problem A here. So Polycarp found a rectangular table consisting of n rows and m columns. He noticed that each cell of the table has its number obtained by the following algorithm by columns. Cells are numbered starting from 1, cells are numbered from left to right by columns, and inside each column from top to bottom. Fine. Number of each cell is an integer, one greater than in the previous column. Okay, fine. 1, 2, 3, 4, 5, 6. Yeah, this seems fine. However, Polycarp considers such numbering inconvenient. He likes the numbering by rows. Doesn't have much time, so you. If in the numbering by columns the cell has the number, doesn't have much time, so he asks you to find out what would be the cell number in the numbering by rows if in the columns the cell has the number x. Okay, so if he has the column number as x, then we can subtract we should subtract n from it as many times as we can, and then we can get the what will we get by that? We'll get the row number, right? Yeah, so int n and m. And can these be up to 10 to the power 9? Okay, x modulo n, right? Okay, we can subtract 1 from it right away because we are considering zero based indexing. So column number equals to x divided by n, right? Yeah, this seems fine. So when I get the column number, okay, 1, 2, 3, 4, 5, 6. So what I need here is, if it tells me the exact number, how can I get the value of the row? So yeah, I am getting the value of the row, right? But then how do I calculate the final value? So yeah, let's see. Seems fine to me, but yeah, let's try it out. Okay, so maybe this should be LL. Yeah, okay, seems to be fine. I am submitting it. I hope this one was very clear because there was nothing much to do here. Like, I'm just extracting the row number and the column number, and then I'm just calculating the value. So like, that's simple brute force. Yeah, this one is right, and I just don't know what is happening on Codeforces. Yeah, moving on to problem B now. So you're given a number k and a string s of length n consisting of characters dot and star. You want to replace some of the stars with x characters so that the following conditions are met. The first character star in the original string should be replaced by x. The last character star in the original string should be replaced by x. Okay, that is fine. The distance between two neighboring replaced characters x must not exceed k. More formally, if you replaced characters at position I and j, then I plus 1 to j minus 1, there is no symbol x, right? Yeah. So j minus I must not be more than k. Fine. For example, if n equals to this and s equals to this and k equals to this, then yeah, this is fine. But for example, the following string will not meet the criteria. Okay, yeah, this seems fine. So what do they want us to do? They want us to find the minimum number of star characters that must be replaced with x. Okay, so the first character is replaced, the last character is replaced, right? Yeah. Can I do like a very simple DP, like if I'm standing at index I and like I can calculate the left index at which I had put in my x before, and that can act as a DP, like okay. So let's just take the input first of all. And are they also telling us that it is always possible? You want to replace some star characters with x characters so that the following initial element, the first character is star. Distance between two neighboring replaced characters x must not exceed k. If you replaced characters at positions I and j and at positions, okay, fine. So like if there is only a single star, then we have to just print one, right? So we can keep the count. Okay. So now can I just store the positions inside my vector? Like wherever I'm getting a star. right? So can this help me in any way? Okay. Now can I run a DP here? Like, or is there a greedy solution to it? Like the first one has to be a star, the last one has to be a star. Right, so if this is a string, let's consider it like this. So if this is a star, then this is marked, this is marked. Now what about the middle stars here? Like I can do a DP very easily here. Hmm. Yeah, that will be like an n cube DP. So an n cube DP should work here. But yeah, let's see if there is still a greedy solution to this. Because I'm not expecting a DP solution in the very second problem of Div3. Hmm. Okay, so I'm doing a DP here. Because n can be up to 50, right? Yeah. Okay, so I'll quickly initialize minus ones. Okay, cool. So what was the last place that we had inserted a x was actually 0, right? Cool. And we don't need the DP to be passed here, so I'll just skip that and I'll pass my size of even minus 1, right? Yeah. Okay, so let's see. I hope this works because it will be difficult to debug now. Okay, 1 1. Yeah, seems to be working fine, so I'll quickly submit it. Okay, wrong answer. So why am I getting a wrong answer here? Let's see. So if index equals to n, that means we've reached the end. So then absolute value of v1 at prev minus v1 at n should be less than equal to k, right? Yeah. Okay. Okay, so what if I have 3 here? I think I read the problem wrong. Replace some of the star characters with X characters so that the following conditions are met. The first character in the original string should be replaced with X. This last character should be replaced. Distance between two neighboring. Okay, let's see. In 10 comma k, so count plus plus. If count equals to 0, then we print 0. If count equals to 1, then we print 1 and then we return. Okay, so here is the problem. So when it said, oh, I'm not checking here, right? Yeah. Okay, now it should be fine. So I was not checking at every point, and that was the mistake. So let's hope it works now. And I've already taken a lot of time in this one because I think there is a greedy solution for this for sure. Yeah, seems to have worked, and it took a lot of time, but yeah, anyway, moving on to problem C. So you're given the strings A and B consisting of lowercase Latin letters. You can do any number of the following operations in any order. If length of A is greater than 0, delete the first character of A, and that is replace A with, delete the last character of the string, delete the first character, delete the last character. Note that after each of the removal, the string A or B may become empty. For example, yeah, for the given strings A and B, find the minimum number of operations for which you can make the strings A and B equal. So I think this is like brute force. Yeah, this is fine. Like you can check every substring of A, right? And what are they telling us? Okay, it can be empty as well, right? Yeah. I can simply store the variables here, right? Yeah. So here I am considering the substrings, and yeah, this should be less than 9 as well. What are the number of test cases? The test cases are pretty small. S3 dot substring. Yeah, so this will give me the substring, and then I can Yeah, so this is like brute force and there is not much to explain here. Okay, I'm not checking anything here, I'm simply submitting it. Okay, actually B took a lot of time here. It shouldn't have taken so much time. Yeah. Okay, a very long queue. This is insane. Okay, so this has worked. Now moving on to problem D here. So you're given an array A of length n consisting of integers. You can apply the following operation consisting of several steps on the array 0 or more times. You select two different numbers in the array ai and aj. You remove the ith and jth elements from the array. Okay. Two different numbers ai and aj. They have to be different. And then you remove them, right? Fine. So we want the minimum size of the whole array. If it is odd, it cannot be, or let's just consider the number that is coming maximum number of times. So if the number that is coming maximum number of times, if it is less than half of the size of the array, then we can remove all of them. Like if obviously n is odd, n is even. If n is odd, then there will be one element remaining. Yeah. So and if it is if its occurrence is greater than equal to n by 2, okay, yeah. Yeah, like we are just considering the number that comes maximum number of times. So if it is occurring more than n by 2 times, then we can consider that number as the first element and the other numbers that are not same as this number as the second number, and we can try to remove as many as we can. And if it is coming less than or equal to n by 2 times, then we can remove all of them, right? Yeah. Can we remove all of them actually? I think we can. Yeah, we can remove all of them if it is coming less than n by 2 times. Now let's see this. So let me just confirm this. So if the number that is coming maximum number of times, let's say this is the array and it is coming so many times, right? So we can only choose these elements as the first element, and these elements, like we can choose this element as the second element in that case, and we will be only able to remove twice of this. Okay, right? Yeah. And let's say it is coming less than n by 2 times, then we can select the other number that is coming like second maximum number of times, and we can pair it up with this, and then we know that the other numbers will be occurring less than, like they will be occurring less times, right? So this should be fine actually. Yeah, it is fine. Okay, moving on to problem E now. So let's just quickly look at the standings. Now problem B took a very long time for me. Yeah, seems to be fine. Okay, so a permutation is a sequence. Okay, fine. Polycarp was presented with a permutation P of numbers from 1 to n. However, when Polycarp had turned into an array Q according to the following rule: Qi equals to maximum. Okay, fine. Wondered what lexicographically minimal and lexicographically maximum permutation could be presented to him. An array A of length n is lexicographically smaller than an array A of. Okay, so whatever the first number here is, like that has to definitely come. Okay, yeah. Then they are saying that it is the max, right? So for lexicographically minimum, like this array will always be increasing. Okay, so whenever we get a higher number, we'll have to put it there, right? Yeah. So like in the Q array, if this is the first element, let's say this is P. Okay, so we'll have to insert P in the permutation P at that very point. But let's say this continues like this. So here we can insert our smallest elements, right? We can insert 1, 2, and then let's say we get Q, and Q will be definitely greater than P because we are considering the max, right? So then we can insert Q there directly, and then we can continue doing that same thing. So this should be fine for minimum. What about maximal here? So if we insert P, then we know that we cannot insert a number greater than Q here. Okay, yeah. We cannot insert a number greater than Q here. So we can consider all the numbers that are less than Q here, and we can put them in decreasing order, and that will give us the lexicographically maximal. Yeah, this should be fine. So I'll just quickly grab some water. Yeah, this should be unused. Okay, so I'm only printing the smaller ones right now. 314275 seems fine. 1234 3451 Now what we need to do here is we can consider the lower bound. What does the lower bound return to us? Oh. I need to find the largest value. I need to find the largest value that is less than my next number, right? So can I start inserting from the backside here? No, I cannot do that. No, I cannot do that. So I need the largest value. I need all the values that are less than q here. Okay, I need to store the next number as well, right? How will I store the next number? Yeah, so this way I'm getting the next number here, right? Yeah, so I can quickly debug that. Yeah, seems fine here. Right, so next we'll have to find the largest number that is smaller than the next number, right? Yeah. Okay, so here we are getting 3, 2, 4. Why aren't we getting 1? Uh, oh, okay, so it cannot be greater than, it has to be less than this number, right? Yeah. Oh my god, this was a blender. This next one was not required. Next number was not required at all. It should have been this. Okay, seems to be fine. But I'm not really sure about this lower bound thing here, because I don't use it much. Let me just still check my code here. So all of this next number was not required. Like, the number should be less than our current number as well. We cannot exceed that number because then the maximum will change, right? So a very long queue here. Okay, so it took a lot of time, like 233 milliseconds, which is fine actually here. Yeah, cool. So moving on to problem F now. Okay, it seems like G is being solved more than F. So let's just try G here. You're given a string S consisting of lowercase Latin letters. While there is at least one character in the string S that is repeated at least twice. Perform the following operation. You choose the index I such that the character at position I occurs at least 2 times in the string S, and delete the character at position I. Okay. While there is at least one character in the string that is repeated at least twice, you perform the following operation. You choose the index I such that the character at position I occurs at least 2 times. Okay. Find the lexicographically maximum string that can be obtained after applying a certain sequence of operations, after which all the characters in the string become unique. Okay. So all the characters in the string become unique. Okay, that is the thing here. So the string that we'll get eventually has to be of length at max 26, right? So repeated at least twice. So it is like looking at this question, I can see that if C occurs, let's say 5 times, so we can keep only one of them, right? That is the thing here. Can I form my string greedily? Like if I know that yeah, if I know that A occurs at so many indices, like these are the indices of A, these are the indices of B, so I know that I have to choose one of them, right? I have to choose one of these, I have to choose one of these. Then let's say so on up till Z I have these indices, so I will have to choose one of them, right? Like if I want this character to be my first character, then if I say that this is my first character and I pick up this one, like picking up these is not it is not necessary to pick up these indices. We can always pick up this index. And how will this help me? This will help me because let's say A comes like this, then it is better to consider this Z, right? It is optimal to consider the first Z. So I can pick this Z provided that the ending, like the last index of all of these, lies towards the right of this. Then I can pick my Z easily, right? And if I cannot pick my Z, then what will I do? Then I will try to, let's say, pick Y. Okay. Yeah, this greedy approach should work. Like I'm starting from the back and I start and I try to pick up that character. And when can I pick that character? Like if I'm saying that I want to pick the kth character, kth means the kth alphabet, then all the letters above this, and all the letters that haven't been chosen below this, like all the letters that haven't been chosen above this and all the letters that haven't been chosen below this, their ending index, like the last index at which they're coming, that should be greater than its first index. And whatever index you choose here, it should be greater than, yeah, it should be greater than the indices that have already been chosen. Like if you already picked a set of characters and they have like they end with, let's say, A, and A's index is, let's say, P, then the index that you choose here, it should be greater than P, and it should be less than the ending of all of the other. Yeah, so this is like a simulation here. And what should be the time complexity here? It should be like 26 into 26. right? Because if we want to put a character, it requires like 26 tries, and for every try we need to check 26 times. So it should be something like 26 cube. So here I'm trying to pick up the maximum character that I can pick here. So semicolon. Yeah, seems to be working fine. I'm not checking it here. Okay, great. So this was like a very simple implementation based question. Not that simple, I would say, but yeah, like there was not much thinking involved here. So Parth is performing really well in this contest. Yeah. Let's try out F then.